You are joining us live from Ithaca, New York, home to Cornell University. I'm your host, Chris Wofford, and today we are joined by Sarah Krebs, who is the John Wetherill Professor in the Department of Government. She's an adjunct professor of law and the director of the Tech Policy Institute at Cornell University. Also joining us, Jesse Goldberg, who is associate professor, and Robert R. Kapranica, fellow at the Department of Neurobiology and Behavior at Cornell. And finally, Bart Selman joins us, who is professor of computer science at Cornell University. Viewers, a couple notes for you before we get started. We are going to ask for a little input from you as we get started and then later on in the conversation. So what we're going to do is kick up a QR code for you to shoot here so we can get some of your input. A couple quick notes. We are live today. We are also going to be providing the recording, which will be available shortly after we're through today, moments after. So if you want to, if you have to leave early, you want to share this with colleagues or whoever later, it's the same URL, same place to join us. So before we get into the conversation real quick, audience, speaking of your input, I want to get a sense of where you are at. What do you think is the most important or interesting application of AI technology that you have seen recently? It's probably difficult to pick one, I understand. Sarah Krebs, let's lead off with you. I should say that I don't know if there's been anything in my lifetime, certainly, I guess the internet kind of comes to mind, that has inspired so much excitement, so much fear, uncertainty, hope, opportunism, and I'll admit a good deal of doom scrolling as artificial intelligence has inspired in me. Google CEO Sundar Pichai says, AI is one of the most important things that humanity is working on. It's more profound than electricity or fire. In terms of historical analogs, is this kind of hyperbole useful? Sarah Krebs.
Thanks, Chris, and it's great to be here. So I think for a lot of us, this is not our first rodeo when it comes to tech hype. We've lived through over-the-top 5G hype. I think it would be hyperbole to say that AI is in the same kind of the fifth element to earth, air, fire, and water. At the same time, I do think that the fact that it touches so many different sectors, everything from medicine to journalism to the battlefield to e-commerce, is relatively, I wouldn't say unprecedented, but I think that does give it a lot of potential to be quite transformative. So I think that, I again, wouldn't put it in the same category as fire, but it might share some similarities as electricity, that certain sort of capabilities were present, electricity comes along and accelerates them. And I think that's akin to what AI can do, is create efficiencies and precision to capabilities, whether it's, again, in medicine and journalism, that were present, but moving at a slower speed than they were before AI.
Bart Selman, any follow-up to that? Any thoughts yourself?
So I actually think hyperbole is a little strong word, but it is a transformative moment, I think, and I'll say more about that in the rest of the discussions. But I think it is a transformative moment and something new that we did not expect to see. I had not expected to see during my lifetime, for example.
I want to look at the audience results here. I mean, overwhelmingly, ChatGPT was the one that our audience feels is maybe the most important or interesting to them. Research, a close second, and then it's kind of all over the map after that. Writing, using to simplify work, process automation. Automation is a recurring theme throughout this, probably a through line in a lot of these. Drug development, medical advancements, medical QA, right? And others. So just interesting to see some of that stuff here. Bart, you've worked in the AI space for decades. You teach master's level students advanced AI. You're very involved in deep learning and other related tech and have been for a long time. What is new with AI that you find particularly interesting or compelling yourself? I mean, where are we at right now?
Yeah, so as I just mentioned, a very interesting time. So we saw a dramatic acceleration in AI with deep learning, which basically uses large amounts of data and compute power and basically neural net style architectures and learning. And the acceleration was in computer vision, in speech recognition, machine translation, also gameplay, AlphaGo, AlphaZero for chess, and even drug development, protein folding. So, but these were all examples of what we call narrow AI. So they excelled at a superhuman level on specific tasks. The general sense among the researchers in AI was what humans excel at is what we call general intelligence. We are very general problem solvers. We can deal with almost any scenarios, and we are remarkably flexible. So this is sometimes referred to as as general intelligence. And then the challenge is, how do you get artificial general intelligence? And we thought this would be another 20, 40 years out. And I like to tell my students, if a researcher says it's 20, 40 years out, they mean they have no idea when it will happen. It could be never. So then ChatGPT, I would say GPT 3.5 and GPT-4 came out, and that was literally around November last year. And January, people started experimenting with it. And I think we have fairly good evidence that it's the first form of artificial general intelligence. So it understands language, and language understanding was the last remaining challenge in AI. And now we have an entity that actually understands what you're asking and understands what it's reading. It's the operating system of the human society. We communicate in language, and we run all our organizations using language and communication. And now we have a system that can understand that and generate it, and come up with insights and answers. I like to view ChatGPT not as a chatbot, but as a knowledge bot and as a smart tutor. We have an entity that we have not had before. So that's why it's so transformative. And I think we're only starting to see the potential of how this is going to change society.
You know, when I spoke to you the other day, Bart, you brought up something that I thought was kind of interesting. You talked about the previous limitations to ChatGPT development when with the advent of 4. You talked about the trunk fitting into the car.
Just a little example. So I taught my foundation of AI course in the fall, and we worked with the precursor of ChatGPT, that was GPT 3.0, and we could easily find many examples that it got totally wrong, and just we like to talk about common sense reasoning. So when I say the suitcase did not fit into the trunk of the car because it was too big, when we hear a sentence like that, because it was too big, you immediately say, oh, the it refers to the suitcase. It didn't fit into the car. If I slightly change this, the suitcase did not fit into the trunk of the car because it was too small, we immediately know, oh, that the trunk must have been too small. That's why it didn't fit. So this is almost subconscious for us. So we don't even, we do this resolving of words and finding the right meaning for it subconsciously. We're not aware of it. For computers, it was remarkably hard. So up till basically the fall of 2022, so last year, computers could not do it, and we had been trying to get them to do it for 60 years. And suddenly, with 3.5 and 4.0, the machine gets this. Google Translate, for example, there are ways to do a similar kind of trick with Google Translate. You can probe it whether it knows it. Google Translate still doesn't know this, but GPT-4 and 3.5 do know this. And this is common sense understanding of language. It's a subconscious process for us. And now the machine can do it very unexpectedly. Last fall, I basically used these examples to show how far AI still had to go. That's why we estimated that 20 and 40 years, and even the founder of deep learning, Jeff Hinton, the godfather of deep learning, thought it would be 20 to 40 years. I think it was something new had to be done. And then they just scaled the model a little bigger, a little more data, quite a bit more, quite a bit bigger. But 3.3.5 and GPT-4 does this perfectly. So now that's a cracked problem, and we did not expect it.
You know, we're gonna talk about ChatGPT-4 and how you use it, how you recommend students to use it most effectively a little bit later in the conversation. But for now, I want to turn to you, Jesse Goldberg. You're doing some very specific and fascinating work with AI Tell us a little bit about your work with reinforcement learning and how it's important for animals, and your background as a neurobiologist and how that kind of fits into the mix here.
Yeah, thanks. I do want to get back to ChatGPT 3.5 and 4 later. I have some things to add to what Bart said.
Right.
But to your question, first, reinforcement learning is a really important framework for, basically that what's happened in AI in the last 10 years is that the systems aren't being engineered to solve a specific problem the way that the early chess playing machines were like engineered to play chess. Rather, there are these large systems that are programmed to achieve some objective, at least in the case of narrow AI, where Bart mentioned. And then the program can learn on its own how to achieve that objective. And it's that learning which is what's making these systems so powerful. So if you think about what we know about learning, a lot of it goes back to animal work. And I think all of us can identify with hunger, which sets our objective to get food, or thirst, which sets our objective to get water. And, we live in Ithaca. And so you can wake up this morning on my walk to lab, I saw a squirrel come to the bottom of the tree, and the squirrel presumably was going around looking for nuts. And the squirrel has to learn where to go. And studying how animals achieve an objective like satisfying hunger to get food has given us a sense of how inside the brain, what kind of neural networks and what kind of signals exist to enable this kind of learning to occur. I'll briefly introduce it. So in reinforcement learning, an animal first sets the objective, hunger, and then if it stumbles upon some tree where it gets an acorn, and it wasn't expecting that acorn, that's a better than expected outcome. It's a surprisingly good outcome. And events like this drive bursts of dopamine in the animal brain. And so a squirrel who stumbles upon an acorn will get a little burst of dopamine saying, hey, whatever you just did, do that again. And that will reinforce an action that led to satisfying the objective. And so that is the animal basically learns a policy for how to get acorns. But in addition to learning a policy, that signal in the brain can tell the animal, hey, this is a good tree. You should come back to this tree in the future because you'll be likely to find an acorn here. So the animal can also learn not just at that moment to go to that tree, but also that is a valuable place. So it can build a value landscape that it can forage in. And the key here is that these reinforcement signals can let an animal score its behavior with respect to some objective. And when you have a value landscape and you're hungry, then you can just go down that value landscape to go to better and better places to get your food. And we have a pretty good understanding as neuroscientists how these signals work in the brain. There's dopamine modulated plasticity in specific parts of the basal ganglia, for example. We know how these signals can build value maps and policy maps. And I think what was most exciting in the mid-90s was when there was this intersection that this learning signal in the brain, called a dopaminergic error signal, is also very powerful in artificial systems. So if you give an artificial agent an objective, learn to play Go and win. You just and you set the rules in place, and the system will explore its moves in the same way that a squirrel may explore its landscape, and learn values as a function of that landscape, and then go down that gradient to get better and better scores. So if you can specify an objective and then score an outcome, then you can build up a system that learns. And it turns out that some of the signals and architectures in animal brains are also useful in AI systems. So for example, an actor-critic reinforcement learning system I posted in the notes of this talk, you can see that there's similar principles at play in animal learning and in game-winning AI systems.
I want you to expand on that a little bit as it relates to animals, parrots and parakeets, and how some of the AI tools that you're working with support neuroscientific work that you're doing.
Okay. So first, a specific example. So what my lab has just studied, for example, is when a bird learns to sing, you could think of it as a vocal learning problem, but we actually see it as a similar foraging problem. The bird forages an acoustic landscape in search of the good notes and gets a dopaminergic reinforcement signal when it hits the right note. So these reinforcement learning architectures can do foraging for food, but also something like vocal learning. So there's a sort of a union between understanding how the brain works and understanding some AI systems. Now, how we can use AI systems for neuroscience research is a whole nother world. So for example, the same systems that enable your phone to understand your voice or to recognize your face, we can redeploy those systems to study animal behavior. So I'm particularly interested in animal cognition. I think people are now starting to realize that animals are constantly underestimated in their cognitive capacities. Parrots are particularly smart. They win in a lot of the animal competitions for cognitive tasks like mirror recognition. They have incredibly large vocal repertoires. And my lab is interested in understanding like what they're actually saying and communicating to each other. And it's not a trivial task. If you were a Martian dropped on planet Earth and you were set to study humans, you would note that they're constantly jabbering at each other, but you'd have a very long shot of understanding that we're actually like communicating the content of our inner experiences. And it's the same if we go eavesdrop on animals. It's very hard to know what they're actually communicating to each other. Now, with these new AI systems that are so good at pattern detection and pattern learning, we can bring them to big data sets of animals interacting and see if we can make sense of what they're saying to each other. For example, does a parrot say, "I'll be right back," right before it flies away and then comes right back? Because they have thousands of syllables they can produce in very complex ways that we're just starting to scratch the surface of. In fact, there's a large emerging field fueled by AI to try to study animal communication and animal behavior. And my lab is just one small part of that.
You know, going on from that, when we had our little pregame conversation the other day, you had brought up neuroprosthetics, which I think is very much related to what we were talking about here. Tell us a little bit about that and how the studies that you just had previously mentioned may influence that, or the research you had mentioned.
Yeah, it's in the same. I mean, it would be in the framework of what Bart said is narrow AI, but I still think it's so powerful. So here's an example. You know, for decades now, people have been trying to restore movement for paralyzed patients. And often these people who are paralyzed will consent to having electrodes put in their brains to try to, for example, move a cursor on a screen on the basis of reading brain activity. And the early systems, like 20 years ago, you could have a paraplegic who'd have a chip implanted in his brain. In this case, it was a male, with 256 electrodes, and what's being detected are electrical signals in the brain. And then there's an algorithm on a computer that's trying to figure out what the person's trying to do. And so first there's a play phase, like 20 minutes, where the person is consenting to following a cursor on a screen with, for example, with his eyes. And then the system will learn patterns of activity associated with different eye movements. And then in the guess what I'm thinking part of the game, the person will just imagine moving the cursor, and then the computer will then move it. And then you could derive some sense, oh, this person's kind of moving the cursor. And that's where we were in 2005. But now it's just come such a long way. It made headlines. You can decode a person who's consenting, that's key, at about 60 words per minute. And in this case, what they did is they just implanted electrodes into a finger part of the motor cortex of a paralyzed person. And they just had the person imagine writing letters in cursive for about, a training session, probably ranging many hours. And they would record that person's brain activity as he was imagining writing a J and imagining writing a Q. And then that was the training stage where the person would be given a cue and would write the cue in his mind, and the system would learn, okay, this is what the activity looks like when this person draws a cue, and then et cetera for all the letters. That's the training stage. And then they say, okay, let's play read your mind. And then the person would then imagine writing his thoughts, and then the system was able to accurately decode the text. And it's just getting better and better. And the way that it works is essentially what Bart introduced is you're training a system to reduce error over a single objective, which is to decode the letter. And so these systems are incredibly powerful. They have wide-ranging applications, as I just said, from animal behavior to restoring some communicative capacity in a paralyzed patient. And I think it's going to be very exciting and worth, ethical considerations when you start to have these systems in play, not just in paraplegics, but more generally, possibly down the road for like enhancement of cognitive capacity.
Bart Selman, computing power has a big, an impact on where we are and some of the rapid developments. Any comment on that?
Yeah, computing power has been essential. So we know data is important. So there sort of three factors come together in sort of to make something like ChatGPT possible. It is the theory about neural net learning, and this was developed in the 1980s, so quite a while back. How to get neural nets to work, to learn from input data. Then around 2000, just with the internet explosion, the availability of data, Wikipedia, all kinds of text sources, everything came online. So lots of data came out of that. And now finally, we needed very fast compute resources, in particular the GPUs. These were graphics processors that were initially developed for video games, actually, for video game playing. So NVIDIA, specialized in video games. And they discovered that, hey, the algorithms that need to run for deep learning are basically matrix multiplication type algorithms, and you could adapt the GPU. You could specialize your GPU to do those kind of calculations very fast. You put this all together, the algorithms, the data, and the GPU power, and you can get to something like a GPT-4. What I find as a scientist very interesting is that ChatGPT does this single word prediction. So it sort of tries to predict the next most likely word. But that's actually sort of a bit of a wrong way to view it, because from that perspective, you think of ChatGPT basically as a chat bot, as a sort of a clever text generation engine. However, what really goes on is it puts that every new word into its buffer, into its window of attention. And because it slowly builds up the conversation, it gets an overall coherence. So it can dive very deeply into a topic by putting one word at a time and then reasoning every time from scratch, almost with whatever it already trained on, to specialize that conversation in a coherent manner. So that's how it can generate hundreds of lines of Python code without any errors, because it knows it's doing Python one word at a time. So we did not think that could work. In terms of language learning, that was a big surprise. We thought what we needed to build was computers, robots that interact with the world. So how a child, think of how a child acquires language by interacting with parents, picking up objects. We always thought that to get at meaning of language, we have to be grounded. So you would have to build robotic systems to do language learning. The fact that we can just train on millions of sentences and build a statistical model for that, and then do this word at a time prediction with a buffer, that would get at the meaning of language was a big surprise. But you need to have enough compute power to do it, and that's why there's now such a political drama over the big chips, because you need the fast chips with regular CPUs. This could not have been done.
Pivoting and jumping off of a question that a viewer just submitted, and this takes our conversation a bit of a different direction, but I think it's time. Anonymous viewer asks, how long will it take for general AI to be comparable to human cognition and decision-making? What are the key drivers, constraints impacting the timeline? We had some discussions about when and how and why AI attempts to act like a human. Can we talk about that a little bit? Does anybody want to take that one?
I could give it a try. I think it's a very interesting question. I think in some ways it is already at the human level, or even beyond that. So I encourage my students to not use ChatGPT or GPT-4 as a chat bot, because that sort of misses the point. I think I tell my students, think of it as a knowledge source, an incredibly rich knowledge source. So you can ask it questions, and particularly you can ask it questions making connections between areas. So we make connections between computer science, mathematics, and philosophy, for example. And what you'll find is you can ask it questions that you cannot find on the web, and you would even have a hard time finding a human that has sufficient depths of knowledge in 3 or 4 different disciplines to get you a novel type answer. So we've asked it kind of questions. I say, well, a human would actually have a hard time, given even access to all kinds of resources, to get the same quality answer as GPT-4 can give you. So GPT-4 is sort of a new entity in terms of a knowledge source that is not found on Earth before it was created. So think of it as an expert, and then you can also ask it to make certain decisions and to make certain predictions, and it is just remarkable at that. So I think we're just starting to see the capabilities emerging that we did not know were possible.
Sarah Krebs, over to you as director of the Tech Policy Institute, what are some of the key issues you're concerned about? What can we do to ensure that AI, and these are things that you kind of consider, right, grounded in principles that put people first, benefit society, there's, elimination of bias, fairness, respect, privacy, transparency, a ton of issues. What are the things that you're thinking about most right now? And sorry if I interrupted you in response to that.
No. I wanted to jump in on this
machines
acting like humans question, because I mean, it's really interesting. It is actually a lot of kind of what we think about it in the policy community. And it made me think as well that we do ask a lot of these machines because we want them acting and thinking like machines when that's what we're aiming for them to achieve. Which is we want the language to sound like a native speaker. So we want it to sound as much like kind of vernacular as possible. But then we want it to be like a machine when it comes to some of the foibles of humans, like machines don't get tired. They don't need to stop for a break. And so we want those machines can then run nonstop, unlike humans can, which is why it has raised some of these questions about sort of the substitutability or questions about whether, that where I think on some level we've moved, I think, away from a pure substitutability kind of expectation and more toward that, teaming kind of dynamic. But anyway, I think it is an interesting point that we want it to be like a machine, like a human in some cases, but we want it acting like just a machine in other ways, which again, does raise some of the issues that we look at in a policy context. So right now, for example, OpenAI, there's often kind of a first mover advantage, but I think in some of these cases there are first mover disadvantages because they got the most attention, they got the most scrutiny. So in Italy, for example, the government banned ChatGPT for a while, which I thought was always, I thought was not going to succeed in the long run. And of course, a few weeks later, the government said, oh, actually, they addressed our concerns. But the US government is now suggesting issued a 20-page letter from the FTC to OpenAI about, quote, false, misleading, disparaging, harmful statements and whether these models are running up consumer protection laws. So we do have then a whole host of issues that are arising about whether these new technologies are legal in some cases, whether they're ethical. Those issues have arisen, for example, with the use of facial recognition, biometrics, the use police using AI to apprehend potential criminals. All of those are, those aren't kind of ones and zeros kinds of questions. Those are questions about kind of values of society, which I think is why we're seeing in a lot of respects different approaches in the US than we are in Europe. Europe is seeing these technologies as much more threatening, I think, to kind of their value structure than the United States, which, and I should say, I talk about the US and Europe, Asia is fully on board with AI, facial recognition and biometrics. So those are the kinds of questions we are looking at is sort of these cross-national differences, how, it's interesting that, many of these technologies do not get released in Europe right away, for example, because they have much more stringent privacy laws, and technology firms have had to pay billions of dollars in fines for running afoul of that. So I think that sort of, we don't have a one-size-fits-all technology is compatible with universal values. I think it's very much sort of society and country specific. So I think those kinds of questions, again, are all important, but we can't kind of cookie cutter our way through them.
I'm thinking about, the common pursuit in business and elsewhere, right? But a lot of organizations are striving and getting there real quick in saving their organization's time, resources, money, human capital, by having AI handle tasks that would have previously taken teams of people. I mean, it's kind of obvious at this point in the conversation to do tasks that people, otherwise don't probably need to do in the future, right? Data management, collation, deep analytics, predictive business functions, creative, generative work, accounting, whatever, right? And of course, they do it better and they don't need rest. And so AI, enables company to grow their bottom lines. It's happening so quickly. Everybody's a little frightened at what rate that is happening. So, when we talk about governance, like within organizations, how do organizations themselves, with board oversight, ensure that like an organization's AI practices and what they're doing is ethical, doesn't present legal challenges, things along those lines? That's a multi-part question, but maybe Sarah, I'll kick that back to you. Who should oversee this if government's going to be constantly chasing it and struggling to provide regulation?
Right. And I think to your point, Chris, this isn't just a question kind of for the corporate world, but we have kind of the public sector thinking about how to deal with kind of personalized education. And AI is great for that, trying to figure out at the individual level what a student needs, when to challenge them more. So that's kind of a public sector question. But, one of the things we're doing in the Tech Policy Institute is looking at the sort of the positive use of AI in trying to bridge gaps in representation between elected leaders and their constituents. And so we've talked to a number of elected officials as we're trying to understand, well, how do they use AI and how might they use AI? And it was really interesting because we've heard many times that, and this anecdote sticks in my mind, but it was a mayor, a Democratic mayor in the Northeast of the United States. And he said he had had challenges getting people to take these jobs. He had a limited budget. And when people did have jobs, their healthcare was expensive, and sometimes they just wouldn't show up. And so he had basically then put a chatbot on this, city's website to answer the questions that individuals were asking or answering before. So employees were, in effect, it wasn't that they were replaced. It was his view or his rationale was, look, these people, I can't get people to work at these wages. And when I do, they don't show up. And now I'm going to replace it with a $20,000 a year chatbot, which is pretty good. It's not like 100% as good as a human, but it's like 80% as good. And it's saving me a lot of money. And so I think you can see and so I think these are sort of open ethical questions. Is that, how do citizens feel when they're putting their question into a chatbot? Maybe they like that more than trying to, make a phone call that no one actually answers, or leaving a voicemail that they know is a black hole. So I think we are sort of going to have to evolve is this working, a trial and error, almost like the reinforcement learning, it's like, members of Congress using these tools, do constituents like it? Do they not like it? Do they feel like this is unethical? And I think firms are having to kind of confront similar kinds of questions. And even in, a university setting, how do we think about our students using these tools? I think, there's a lot of debate about that. It seems in a lot of ways, it's unrealistic to expect that they're not going to use these tools. I mean, when you talk to people between the ages of 10 and 25, 30, they're all using these tools. And these are all increasingly seamlessly integrated into search engines. So I think there's a way in which now this technology is so ubiquitous, it has proliferated so much. It's a question of how to shape the norms rather than to expect that we're somehow going to undo these advances.
There's a couple questions here. I'm just going to synthesize them. A couple of viewers. Thank you for that, Professor Krebs. Some viewers are curious about how AI is being used at Cornell. Bart, you had kind of discussed this a little bit. One viewer asks, where are we? Is Cornell utilizing AI for education, fine-tuning LLMs based on specific curriculum, therefore getting responses based on data Cornell accepts for education? All right, that's getting a little bit ahead. But tell us a little bit about how you think about teaching AI and what your approach is and the outcomes and objectives you strive for.
Yes, so and I may have a little bit different view than a lot of educators. I think GPT-4 is an incredible resource. So I think what we have to do in education is allow students to fully use these models. In fact, a key thing in using something like GPT-4 or ChatGPT is what questions do you ask? How do you ask the right questions? How do you evaluate its answers? If it gives you a coherent, logical argument, then you're quite confident that it's correct. But you actually have to be careful about fact checking and things like that. So I want my students to use these things, the ChatGPT as a resource, and in particular ask questions that they would like to have been able to ask a professor. But you can't just call a professor in the middle of the night with your question. So when you're studying a subject, it's an incredible resource to get new insights. And so you learn a lot by using it. And I think we actually will go through a period in time now, and not just at universities, but at companies too, and at organizations, where we will collaborate with something like GPT-4. This happened also, like an interesting analogy is with computer chess. So after, this was many years ago, but after Deep Blue, this was 1997, I think, beat the world champion, there was a period for about 15 years where the strongest possible the strongest possible way of playing chess was a combination of humans with computer chess programs. So that hybrid was stronger than any individual team. So it was stronger than the best human, stronger than the best machine. So this combination of human machine was actually far superior to anything else. So with GPT-4, I think we're moving in a period like this. So the next 10, 15 years, the combination of us working with these language models will be better than anything else. And for educators at the university, it's our job, I think, to make sure that the students learn all about this and learn how to make use of ChatGPT as well as they can. And I think it's very interesting because it forces you to be critical about your thinking. It forces you to ask the right questions, to delve deeply. So it's a very interesting interaction if you actually try to get some new insights that you could not get any other way. So suddenly, you can be sitting at home and you can ask a smart computer science professor, you can ask a smart mathematics professor, a smart philosophy professor, you can ask anybody in the middle of the night and they'll give you new insight, but you have to go and do it. So I tell my students, don't use it just to summarize some text or to write an essay, which is nice use, or write an email. Those are nice uses. But for me, the real use is go for its knowledge and see what new perspectives it can bring you. So I think it's an incredible opportunity for education.
Jesse Goldberg, I see you gesturing over there. Any
Well,
thoughts on that?
I think Bart speaks of a beautiful era where the human AI interface is outperforming the AI alone, but in chess that didn't last very long, right? So now it's best to get the world's best chess playing human out of the mix, so that the real powerful AI powered chess system can win, because the human's just going to muck it up. But I don't necessarily think that's the metaphor for education. I don't think that we're ever going to get the people out of education. But I do want to get back to something you mentioned about, I thought you explained really nicely about how ChatGPT is trained to predict what's going to happen next. But that's just missing the, well, what I would say is the beauty of how it works. So in some sense, independent of the ethical implications and its utility, I'm just fascinated by how this system is trained and what kind of knowledge it acquires. I think it's almost magical that you feed this system, granted, billions of pages of text, and it's got these deep networks and these powerful learning rules. But in a sense, the objective is just to predict what's going to happen next. And it turns out that to do that objective very well, you really want to have a fundamental and deep understanding of everything going on in its small text-based world. And I just know that in neuroscience, there's been, for many, many years, there's been an emphasis on what's called error signals in the brain. So if you have a mouse running on a treadmill and it's got a periodic lines or walls that it's passing, the brain learns, okay, this is the structure of my environment. But as soon as you throw in something that was unexpected, then the whole visual cortex lights up like, ooh, I didn't expect that. And then you can then, over experience, the animal then learns to expect it. So we have reasons to think that a big part of human and animal sensory systems are tuned to predict exactly what's going to happen in the next instant. And in a sense, that's what the LLMs are doing on words. And so I think as we move towards more general intelligence, I don't know if I mean AGI, but like If you start throwing many modalities into the mix, movies, or just real life embodied robots going around, and you're just trained on what's going to happen in the next instant, then they're going to learn the physics of the world. They're going to learn that an apple that falls, it's likely to fall vertically down from the tree. You don't need to program in an understanding of gravity. It'll learn the physics of the world. And by learning what's happening next, it's just a powerful way to get an actual understanding. Because if you understand what's going on around you, then you can predict what's going to happen next. And I just want to tell one brief story here about how emotional, because when we experience these moments of emotion, that's actually when the learning is happening, because these are these expectation violations. And predicting what's going to happen next, if you have a toddler, you can really see in front of you how powerful the desire to know what's going to happen next is. So I was pouring my son a cup of juice, and I started pouring it, and I realized I was accidentally pouring it into a cup that had last night's wine in it. And so at the last minute, I moved over to an adjacent cup, which was an identical cup. But as soon as I switched which cup I was pouring it in, my 2-year-old had a complete tantrum, insisting that I pour it into the cup that he initially thought I was going to pour it into. And I think what this funny story shows is that when we learn about the statistics of the world, we're desperate to know what's going to happen next. And I think what I've learned from seeing the success of ChatGPT is that, this makes sense. Like, you want to predict what's going to happen next as your learning rule, so that you can almost, I don't want to throw this word out willy-nilly, epiphenomenally learn about the basic structure of the world and actually understand the world around you. So if you want to build an animal or an agent that has a deep understanding of the world, then train it to predict what's going to happen next.
Exactly. If I can add a little bit to it, you mentioned the apple falling, and so the apple falling was exactly what we used, in the fall with GPT 3.0, and showing that it couldn't know that because it never seen an apple fall. To me, a big surprise in GPT 3.5 and GPT 4 is it knows what happens when an apple falls, and it knows about naive physics. So somehow it's gotten it out of text, which actually to me was a total surprise. So it's never seen an apple fall. It doesn't know what happens. And if you ask it, what would happen on Earth if gravity was 1/10, it will give you a pretty good answer.
Wow.
So it that it could get that just by reading is actually quite surprising. But you're quite right. To do these predictions, in my mind, to do the predictions right, it has to have higher level concepts. It has to have an understanding of a much higher level of the various concepts and how they relate. Otherwise, you can't predict as well as it does. So it's forced to actually develop that. But even naive physics, it actually has developed. So it was a big surprise.
Several viewers are asking about the anthropomorphization of AI. Let's get into it. I just want to ask, what are the risks of AI? Why is it presumed AI will soon be out of our control, right? I mean, we certainly control it. We designed it. Sarah Krebs, I think I'll kick it over to you. You want to discuss about the paperclip scenario. Are we somehow missing the point or making an error in anthropomorphizing AI? Experts are sort of all over the place, and there's this constant questioning about the existential risk that it poses to humanity and so on. That was a 5-part question, but Sarah Krebs, I think you know what I'm getting at.
Yes, thanks, Chris. Well, so one of the reasons I think a lot about risk is that if you want to think about what the policy should be or what the constraints should be, you probably want to know kind of how perilous this technology, what the perils that it presents are for society. And when you start to dig into the expert assessments of existential risk from AI or catastrophic risk from AI, is really all over the map. And what's further interesting, and there was a great study on this that just came out this week on how, and this is a finding that I think we've seen in different domains, but it was Sam Altman, who's the CEO of OpenAI, has kind of talked about this existential risk. And one of the kind of interesting things about assessing risk is that often subject matter experts will put the risk of that issue as being considerably higher than people who are referred to as kind of super forecasters. So the Forecasting Research Institute just put out this really interesting paper from a long-run forecasting tournament. And the sort of summary of this was that when posed with the question, so there were all different kind of scenarios of like nuclear catastrophe, AI catastrophe. I work in both spaces of AI and nuclear. But on the AI existential risk, so domain experts put the risk of an existential crisis, which is defined by, in a 5-year period, the risk that 10% of the population will perish as a result of this technology. So domain experts put that at 12%. Super forecasters put that at 2%. And within those domain experts, there so much kind of contention about what the risks pose. I think when things like ChatGPT first came out, it was, well, they're going to put people out of work. Well, in the US, we're at historic lows of unemployment. I don't think that is presenting kind of this, I would not put that in the existential risk category. The paperclip scenario that you talked about is the one that I've sort of heard people talk about. I think it seems often in a caricature kind of way, but where you program this machine to optimize the manufacture of paperclips. And then anything that gets in the way of that machine then is just eliminated, kind of Terminator style eliminated. That also seems a little bit fanciful to me. One of the things I studied that I wouldn't put this at the existential risk level, but I think is a risk, is when it comes to kind of these national security battlefield applications. If you're now programming a drone or programming a nuclear command and control system to identify incoming targets and respond immediately based on what it detects as an incoming missile from Russia. And we know we've had those scenarios before, and there are a number of historical examples where humans overrode the system. Those are the kinds of scenarios that I think could be more existential, but I don't think the US is not talking about turning over its nuclear arsenal to AI. But I think if we want to kind of outlandishly think about kind of the tail risk of AI, those kinds of scenarios, I think, would come up, even if I don't think they're plausible.
I should allow for Jesse or Bart to comment. Bart, did you have something to say about risk?
Oh, I was just going to follow up on the military.
Yeah.
So I actually agree with everything Sarah just said. And so I think the impact of AI will be more like how can we adapt, and it will impact society in significant ways. Is an existential risk is much harder to judge. The military risk I am a little bit more concerned about. I remember years back, discussing with DoD people about the human in the loop scenario, which seems totally reasonable to me. And I was surprised to discover that, in designing their systems, if they designed, I think these were smart missiles, they actually preferred that the missile could not be interrupted. And the reason for that is they say, if we make it so that you could send a signal to stop the missile from its trajectory, then your opponent could also potentially send that signal. So we prefer to make it fully autonomous and uninterruptible. So it's a scary kind of thing that there may actually be forces that they say, well, no, we cannot keep the human in the loop, because that would actually be risky if somebody misuses that. So I think the military issue is something that we have to be careful about. But in terms of sort of others, so the paperclip scenario, I think is a little further out. But I do think that as humans, we have to understand there has to be a public education, sort of what these systems can do and cannot do. And we shouldn't overestimate it, but we also should not underestimate it. And we should really look for how can we use it in a positive way, even in policy and decision making. I think AI can improve policy and decision making, and can improve governance if it's done in the right way. So I think there's tremendous opportunity actually to make things more efficient. And with population going down, actually now most Western countries, it actually may help us live longer independently, elderly care and assistance and things like that. So there's tremendous opportunities to have AI assist us in many different ways.
So I want to jump back to governance in just a moment, but Jesse, I should ask you, are there scenarios in your research, in your lab work, where you're thinking about risk, where you're thinking about threat, things that are bringing you sources of anxiety? or that maybe that doesn't apply here?
Actually, no, I don't. I mean, if we're better understanding how parrots are communicating with each other, I'm not too anxious about that. I don't think they're out to get us. I mean, in some ways, if anyone has read the Chronicles of Lewis and Clark, Lewis and Clark and their team and their expedition at my sense is they were such truly good, progressive people on that expedition. They didn't think they were better or worse than anyone else. It was a diverse expedition. There was an African American on their expedition that was treated as an equal. They were respectful with the Native Americans. They were received well by the Native Americans, and they explored. They were explorers, and I don't think that they were thinking about everything that might happen if they really chart this territory as well as they could. And I think it was Lewis who went into a deep depression later in his life when it came out, what the oppression of the Native Americans turned out to be, in part fueled by the exploration they did. So maybe I should be a little more anxious, but it's just hard to know. I think it's important to bring a lot of different groups of people together, because I think it's often the case that the researchers are just excited about the next discovery or breakthrough, much like Lewis and Clark might not have the lens on the bigger picture. So I think I can say that I don't have that much anxiety, but I'm mindful that there are other people that maybe I should be paying attention to who do, and who know more about history and the long-term possible impacts of these kinds of disruptions.
Yeah. We have a viewer here who asks, and, I should just say uniformly, not only this panel here that I've spoken to, but most people say the cat's out of the bag, right? There's no putting a pause on this. There's chatter about it every day. There's, proposed legislation and oversight. But one of our viewers asked, should we be looking at the EU, the European Union, or even China, as they seem more advanced in setting policies for AI development? Not sure the Federal Trade Commission will be effective in their pursuit. So let's talk about potential oversight. I suppose, Sarah, you might be the logical place to start there.
Yeah, I mean, I think this is a tricky question, because it gets fundamentally at societal values. It's like when we think of training an algorithm, we want to tell it what to optimize. And, if you think about society, you could optimize a lot of different things. And actually, there was a great piece in the Wall Street Journal recently about Europe, and their GDP has stagnated since 2008. And when they talk to people in Europe, they say, you know what, we really just value our leisure. We just honestly don't want to work that hard. And that's fair. That's a value. And I think, but if you think about Europe as well, it's a chicken and egg. Maybe they have this skepticism toward tech because none of the tech firms maybe the tech firms aren't in Europe because they had that skepticism. But certainly by sort of restricting tech, they're not kind of undermining their own innovation. And I think what the US approach has been is a lot more enterprising, a lot more sort of pro-innovation. When I think about, for example, and something I teach in my classes, I was teaching both a law school class and a class for undergrads this semester on AI. And we were talking about the 1976 Copyright Act, which really has a very pro kind of fair use assumption as to how new technologies, I mean, it's amazing because it's the 1976 law, but it's been used to think about how we should consider these new technologies. And Australia will interpret new technologies, kind of the question of who owns the rights of the data and the stories and the authorship that has gone into train these models. I think Europe and Australia, places like that, are much more of the view, hey, that's their copyright. The US has generally interpreted these new technologies in a kind of fair use way of, look, we need to adapt to the new to new technologies, and we don't want to stifle that through kind of overly restrictive regulations.
Right,
Yeah.
and if I
Go ahead,
can
Bart.
answer, yeah, I actually think that existing law actually already does a lot for us. So there's, for example, big concern about deep fakes and somebody sort of pretending to be you and then scamming your mother out of money or something like that. But of course, that's illegal already. So even if you would just pretend to be somebody else. No, don't use AI and try to scam somebody. Existing law will come after you. So existing law actually covers a lot of cases that, even if you now use AI in doing unlawful things, existing law can be applied. So I'm sort of hopeful that will work out. As for the copyright, I guess I'm actually. I'm thinking of books, I guess. I actually think all textbooks and all scientific text should be public domain, and so I want my GPT-4 to have read all the textbooks in the world. So I'm actually hopeful that we can actually have models, and they have actually done that. They've read tons of textbooks. So I hope there's not going to be a law that says you're not allowed to train your deep net to understand physics. So I actually think that we have to be a little, a little open to the possibilities that these things offer, and there's a trade-off between sort of copyright and things like that, but we should also see the positive aspects of it. Reading all the physics textbooks is actually an interesting thing to do.
Making predictions about artificial intelligence has been tricky, right? We don't know what's going to happen from one day to the next. One of our viewers asks, however, when will there be competition to ChatGPT to give us other cups to choose from, right? So, I just read the other day about the Bing chatbot that didn't have a good interaction with a New York Times reporter, ended up somewhat disastrous, and that chat that chat AI started to indicate hostilities and so on. I don't want to get too crazy with this, but I do want to ask, what's next? Where's the competition? Who's going to be working in this space in the near term? Do we see anything emergent as something that's possibly as revolutionary as ChatGPT-4, I suppose?
I think we'll see a lot of it, and a lot of companies will go for it. I think a very interesting point is it has to get to a certain level. So you have to get the GPT-4 level to become interesting. It's amazing that if the model isn't quite big enough, it isn't carefully trained enough. GPT-4 was very carefully trained, giving more emphasis on books than on blogs, or more emphasis on very high quality text than other text. So, but the cat is out of the bag. So we know it can be done for a few $100 million, and there are lots of organizations that have a few $100 million. So we'll see GPT-5, GPT-6, and that could come from anywhere. But it has to be done right, and that's the surprising thing. It has to be over that threshold of quality, because if you're below that threshold, you actually get pretty bad results. Yeah.
Jesse Goldberg, viewer Mark asks, as the computing power continues to increase, is that limit equivalent to a neural network? So forgive my ignorance, but computing power as it relates to a neural network, do you think about those kind of things?
Yeah, all the time. A lot of these AI advances are fueled by neural networks, which are basically units. You could call them cells or nodes, and they're connected to one another in a network, like neurons in the brain are. And through learning, the connection strengths change. And that's basically it. In all of your life experiences and memories, and in the machines that are predicting what's going to happen next and having understanding of the world. So connectionism, which was actually born at Cornell by Frank Rosenblatt, who made the first, the perceptron, really had its origins here about 60 years ago. So the parallels are really striking. The architectures of these systems, in many cases, look very brain-like. And that's actually explicitly studied in the context of face recognition systems, which are very well understood in primates and in machines. And that's why I'm a little bit hawkish on anthropomorphizing AI. If you're a materialist, which you don't have to be, I happen to think that my thoughts and feelings arise from the physical world. And if you are a materialist, then it follows that there's no limit on the extent to which a machine could capture some aspect of human experience. I don't think we're close to that now, but there's no ceiling unless you invoke something divine, which I think everyone is free to do, and maybe I'm increasingly doing these days. But so there it is. So I think that the connectionist models, neural networks, have triumphed, and maybe they'll stay the.
And I can add a quick additional thing. So one thing that's a little different is the digital hardware. I agree that it's essentially modeling our neurons, but the digital hardware is more scalable. So you can actually, so the human brain doesn't scale, doesn't grow very fast. Digital hardware and that keeps the speeds keep increasing, and you can do huge amounts of parallelism. That's why you can train 1,000 different areas of human expertise and combine all that knowledge together. It would be hard to do in a biological brain. So,
beautiful answers, Jesse and Bart. Thanks for the question, Mark. Sarah Krebs, take us out. What gives you the most hope? Where do you see the most promise? Let's end on a positive note here. What do you see?
Well, I actually think that our panel has been, fairly optimistic. I don't think
that's right.
don't think anyone has come across as doomsday.
No.
I think what I see these technologies as doing, whether, it's in radiology or in biology or in the economy, is economizing on kind of the limits of human kind of cognition and time to free us up to do kind of more creative tasks. And I think that's what AI is going to help us do, is kind of create that space to be even more innovative and creative.
Yeah, perfect. And I didn't mean to mischaracterize the conversation that has happened thus far. I mean, it's been very sober, very measured, very illuminating, and which I appreciate. I'm so glad we kind of stuck in that space. I want to thank all three of our panelists, and for viewers, excellent questions. Thanks for your engagement. As mentioned, this recording is going to be available shortly after we're through today. Bart Selman, Jesse Goldberg, Sarah Krebs, absolute pleasure. Thank you so much for joining us today for today's conversation.
Thank you.
Thanks,
That's
everyone.
fun.